Hello everyone, welcome back after 1 week. I hope everything is okay. Today we're going to continue with our lesson about angles between parallel lines. So I try to hurry a bit, but not too much, so you guys don't get lost. But let's get into it. So in the diagram below, S is parallel to D. So yeah, line S. Let me make this stronger. Line S is parallel to line T. Okay, I get that. Find the value of x. Okay, first let's see what we can do based on that. Um, okay, I see something here. So what I see here is that this angle right here and this angle right here make a z between them. You see this? They make a z between them. So they are alternate angles. Alternate angles. And what alternate angles do is that they are equal. So I can say that 5.5x plus 12 is going to be equal 3 times 3.5x minus 8 over 3. So in this case, I'm just going to multiply times multiply this. So 3 times 3.5 is 10.5. 3 times 8 over 3, which cancel out the 3's and is minus 8. So 5.5x plus 12 equal, oh, this is x, sorry. 10.5x minus 8. So now I'm going to subtract 5.5x in both sides, 5.5x, and also um add 8 in both sides. So in this case, you cancel out this. In this case, you cancel out this. So what you get is 12 plus 8 is 20 equal 10.5 minus 5.5 is 5x. And we divide both sides by 5 and we get that x equal 4. And yep, this is our answer. It's equal 4. So I'm going to move this to the side. Oops, I didn't want to take the aquí está. Oh, like yeah, here we go. We put it here. So now the next one we need to find the value of x. Oh wait. First you can say, oh, why are we using this angle? But as you can see, we didn't need it. There has been like hundreds of times, like a lot. This is going to happen a lot. I can tell you that they are going to give you extra information that you don't really need to solve the exercise. So don't get like confused or like dubitative about it if you see that you're not using some of the information they give you in these exercises, because sometimes it's just like to distract yourself from the real objective. So let's continue. Oh, in this case, there is a theorem that your professor might have tell you in class, that I really think is kind of like important, I would say. But there is a lot that we can do without it. I'm just gonna well, never mind. I'm just gonna use the actual angle, like the angles property we have been using, so I don't confuse you guys. So let's do it. Okay, you guys get what I'm doing. So I can say I'm visualizing this and seeing this line right here. This is a good line, and I say that this angle and this angle make kind of a Z. You see? Like Z. So that means that they are consecutive angles. Consecutive angles. And consecutive angles add up to 180 degrees. So, also you might say, but these two angles, I'm just considering as a whole. So it's just adding those two together, it doesn't matter. In this case, you see, it's the same if I have this and I consider this too. It doesn't matter. So I would say that 7x plus 26.8 plus 2x plus x plus 3.2 is all equal to 180 degrees. So now I have the 7. Like I'm going to to add likely terms. So this 7x, this an x, this another x, then this a number, this another number. So I'll say that 7x plus 2x plus x is going to be equal to 10x. And then 27.8 times 3.2 is going to plus 3.2 is going to be equal to 30. So 10x plus 30 is going to be equal 180 degrees. Now we subtract the 30 from both sides and we get that and x is going to be equal 150, and we divide by 10, we get that x equal 15. And this is our answer right here. Now let's continue. In the figure below, BD is a perpendicular bisector to AC. Find the value of x. So first, what I was telling, I think I told this before, that if we see perpendicular, first I'm going to divide this by part. If we see perpendicular, it just means that it's intersecting the other line, creating 90 degrees angles. Now, if we see the word bisector, it means that it's dividing in equal parts. So this side is going to be like the sides that are created, the two segments that are created are going to be equal to each other. So what I would do, so since we know that AB is therefore equal to BC, I could say that negative x plus 25 is equal to 3 times 2x minus 8. Now, we have everything we need to solve for x. And first, I'm going to multiply this side. So I'm going to keep negative x plus 25, negative x plus 25 equal 3 times 2 is 6x. We skip the x, and 3 times 8 is 24, and it is negative, so minus 24. Now we add 24 in both sides, and we add x in both sides. So this is plus 24, plus 24, this is plus x, this cancel out and this cancel out, and we get 24 times plus 25, 49. 49 equals 7x. Now we divide each side by 7, and we get that 7 is equal x. And this right here is our answer. Now continuing, okay, in the figure below, AD is a perpendicular bisector of CV. So I know that AD is making a right angle here, and this side is equal to this side. Okay, Based on this information, select all statements that are true. Okay. So first, there is another property. Like, this is basically a definition of a isosceles triangle and also an equilateral, but all equilateral are isosceles, so that makes sense. But what I mean is that all isosceles triangles, they have two equal sides, and this is going to be called the base because it's the side that is different. But the perpendicular bisector of all isosceles triangle that goes from the opposite side to the equal side, the opposite side to the base. To the base, like this vertex to the base, it is a perpendicular bisector. Like all the line that goes straight to the base or to the middle of the base or that goes perpendicular to the base. It's just like, I don't know how to explain it well because it's just like a property you must know, or at least like you are aiming for really hard questions, like for a level 5 in your exam, something like that. It's just that we practice. It's something that we practice. You get kind of stuck in your memory, basically, and you get this specific property. So, based that this is a perpendicular bisector and it goes from the vertex to to here, I know this is going to be the base side of a isosceles triangle. So this side must be also equal to this side. So based on that, I could say that 7x minus 17 is going to be equal to x plus 48. So when I'm solving for this, I'm going to subtract 2x from both sides. So I get 5x and add 17 are equal 48 plus 17. That's going to be 65. Now I divide by 5 and I get that x equal 13. And that's basically the value of x. Yeah, I didn't make any mistake there. As you can see, this is not true. So let's see. AC equal 35. AC, let's calculate it. So I have that 7 times 13 minus 17. So 7 times 13, 7 times 3 is 21. I get 2, 7 times 1 is 7 plus 2 9, so 91 minus 17. And 91 minus 17. It's better to do it this way. Sorry. So 11 minus 7 is 4. I get 1. So 8 minus 1 is 74. This is the answer. This is not 35. Now, CV equals 70. Okay, CV is the composition of these two sides. Like this side all the way to here and this side all the way to here. So basically, I know that these two sides are equal and this side is 35. So this other side must be also 35. So 35 plus 35 equals 70. So yes, CV equals 70. Now AV equals 74. Okay, we either could calculate it again, and I telling you it's going to be 74 the answer, or we can just assume that this side is equal to this other side, and we already know that this side is 74. So this side is also 74. So yeah, this is true. Now, okay, ACD, ACD equals 45 degrees. We don't know that, but there is a way we can like kind of know it. Like basically we know that this is a 90 degrees angle, and if this is a 35, 45, and this is a 45, it would just mean that this is also an I'm trying to do it without a calculator. Like there is an easier way with a calculator, but since we don't you don't really have an access to that kind of calculator in the exam, and you're trying to do it without one. So we have this 45 and this one also 45. This would just mean that this side is going to be equal to this side, and that's going to be an isosceles triangle because these two angles are equal. Like in an isosceles triangle, the base angles are equal to each other. So this side must be equal, and we can calculate actually the length of this side using Pythagorean theorem. I know that c squared, which is the hypotenuse, is going to be equal a squared plus b squared. And we are missing b squared. So b squared, I'm going to pass like subtract a from both sides. I get that c squared minus a squared equal b squared. So b will be the square root of c squared minus a squared. So we say that c is the hypotenuse, so it will be 74 squared minus 35 squared equal b. Now this calculation we can actually do in the calculator. I'm gonna use this one. I'm going to say okay, square root of 74 squared minus 35 squared. And as you can see, it is not 35, it is around 75.2. It's around 75.2. So nope, this cannot be 45 because then it wouldn't be like it needs to be equal, those two sides, for it to be 45. Just explain it a little bit more about that. Maybe you didn't understand why I chose the 45. It's just because all triangles can have up to 180 degrees. Like is the measure. The measure of the three angles of a triangle, like this one, this one, this one, is 180 degrees. And since we already have um a 90 here, we only have 90 more left. So 90 divided by 2 will be 45. Or if we say 90 minus 45, then we know that we have another 45 left, so it needs like to be an isosceles triangle. So no, this is not the answer. And now ADC, which is this angle right here, is a 90 degrees angle. Yeah, that's true. Because it's a perpendicular bisector. And perpendicular means that it makes a 90 degrees angle. So that's basically for this exercise. Next. Monica is working on the proof below. Okay. Select the statement and the reason that Monica is missing from her proof. Okay, first, let's see. CD is a perpendicular bisector of AB. Okay, so based on that, AC is congruent to CV, a measure of angle DCA, and angle DCV equal to 90 degrees because of the definition of perpendicular bisector, which is what I was explaining before. Now, I will say that DC is congruent to DC. We have like a question mark here, and then SAS. SAS means side angle side, which is basically making two triangles equal. So first or all, I'll see, yeah, corresponding part of congruent triangles are congruent. But what I want to say first is this. So for the first one, I will explain a little bit what is transitive property. So transitive property is that, for example, I have Measure of angle 1 equal measure of angle 2. Measure of angle 1 plus measure of angle 2, angle 3 is equal 47. So, because of the transitive property, I can say that measure of angle 2 plus measure of angle 3 equal 47. And just like changing the measure of angle 1 by the measure of angle 2. That's the transitive property. So this has this right here has nothing to do with it since it's just the same line. So I can get rid of A, I can get rid of B because of that. And now for the reflexive property, it just means that angle 1 is congruent to angle 1 because it's like the same thing. So that's basically it. Now let's see. DCA, I will say now is talking about the triangles. This is DCA, DCA, and now DCB. Okay, okay, let me use another color. Okay, DCB. Okay, and now let me see this one. This is DAB. Okay, this third one is the okay. I again select the right color. Sorry about that. So this CV, as you can see, this is DAB. I'm sorry. You can see this is not the triangle we're looking for, definitely. So this is not my answer. And you can see that now our answer finished being same part C. And that's because also you can see like another way to do it instead of just looking at the answer is that you see they are talking about side angle side. So we will have one side which is AC, AC, um, CB, AC and CB. We have two angles, which are this one and this one. They are here, DCA and DCB, which is 90, and we have DZ. And as you can see, the two angles that correspond to this specific, the two triangles that correspond to this specific measurements are the CA and the CB. So that's another way to do it. And that's how I know it's C. Now let's continue. Okay, I know that ABD and ABC form a linear pair. Okay, linear pair is just that they are in the same line, as well as wait, ABD. It is an angle ABD and ABC linear pair. Okay, they're over the same line, and then CBE, ABC also for a linear pair because they're over the same line. Okay, perfect. Now I know that angle ABD, which is this one, plus an angle ABC, which is this one, are supplementary because they are over the same line, basically it. And they are because they add up to 180 degrees. That's the definition of supplementary. We should know that because they are linear papers today. So if two angles are over one straight line, they're going to add up to 180 degrees. Um, and when A and CBE and ABC are also supplementary because of the same reason. Okay, now we say that these two pairs, like each one of those two pairs, are 180 degrees, and they're asking us why. So I'm going to come here. First of all, this is going to be really easy because they're saying that it's supplementary. So we see supplementary here and we see supplementary here. Complementary has nothing to do, since complementary is when they add up to 90 degrees. Um, they already said supplementary in the given part, so it's just kind of makes sense. Now, okay, we have there because they are supplementary angles, and now substitution property equation. Okay, that's that can be a tricky question. So, um, okay, perfect. So what I will say is that the substitution property equation is just that you have the value of one thing constituted by the other thing. For example, what I would say without looking at the answer is that I know they two equal to 180 degrees. So I will say that ABD is obviously measured angle, but I'm just trying to write it really quick. Plus ABC is equal. I have that this is also equal to 180 degrees. So CBE plus ABC. And when I look at my answers, I kind of know this is not going to be the answer because we have never talked about EBC, although it is the same angle as CBE. But let's just see what we have here. Okay, yeah, definitely this is not what we're looking for. We also say that DVE is this angle, and we are not talking about this angle at all for now. So this is not my answer. And now, when we see here, I have ABD, ABC, which is what I wrote here, the first part, equal CBE and ABC, which is the second part, what I also wrote here. So very good. This is our answer. And just to make sure, let's continue reading to see. Now, okay, ABD equals CBE, subtraction property, and that makes sense because we just subtract ABC from both sides. We subtract ABC from both sides. We cancel this and we cancel this. And we get with this too. And therefore, they are congruent because they have the same measure, which is for the congruent angles. So it all makes sense. Now let's do this last exercise. So a diagram is shown where K and L K is parallel to L, so K is parallel to L, and M is transversal. It just means that it's passing through these two lines. Okay, perfect. Let's see. Oh, I'm trying to make it perfect, but either way. So first we have the given and now corresponding angles. Okay, we want to prove that 1 and 5 are corresponding angles, so are congruent. So either way, we want to use one of the two for the corresponding angles. So first we want to use one of the two for the corresponding angle. So I know that it's not A because it have neither 1 or 5. Neither 1 or 5. So this is not my answer. In this case, it's also not B because this is our final statement. And since it is our final statement, we can use it. Now also 2 and 4 are not corresponding angles and 1 and 5 are not corresponding angles. Now we have 1 and 3. As you can see, 1 and 3. They form an F. Let me show you. If you write it, they form like an F to the left. So yeah, they are corresponding angles. So it will be angle 1, congruent to angle 3 because they're corresponding angles. Now, what we want to do is now make angle 3 and angle 5 congruent as well. and they say that angle 3 and angle 5. So we can kind of, if angle 3 and 5 are congruent, then 1 and 5 are congruent because of a like substitution or translated property, or the one that we use here, which is it was like substitution property. That's what it was telling us. But the other one here is translated property. And they both work. It's kind of difficult to select like if they're like they are both the option. I don't think they're going to do that because it's like really really difficult to differentiate between the two. So either way, what I was telling, now you want to make 5 congruence, like a relation between the two, so you can actually compare 1 and 5. So what you're gonna do is say, okay, angle 3 is congruent to angle 5. Okay, which is what we have right here. Now 4 and 6, we got that. Okay, they're congruent, but it's not gonna help us to achieve like our final like objective. So this is the answer. Now part B. Select the two main spaces. So here 3 and 5, like I know they're congruent. We know they're congruent because there is an X right here. There is an X right here with, so they are vertical angles. As you can see, this is not the answer and this is not the answer. But these two vertical angles. Now, um, we need to select between reason 3 and reason 5. This is actually kind of difficult because the symmetric property is like very specific as well. It's like very like what we are doing, but uh the answer is part B because it's what I explained it before. It's like we are transitioning property, so we know angle 1 it goes with angle 3, angle 3. But we know that angle 3 also goes with angle 5. So based on the transition, like the transition of the thing, we can cancel. Oh, this was supposed to be 5. We can cancel the this and we can say that angle 1 goes with angle 5. That's how it works. I hope you guys understood that. Let's do a last one so we can finish the page. Let's see what we can do. So, given the 2 and 4 are vertical angle. So this is an x, and they are equal. Prove that angle 2 is equal to angle 4. Okay. Okay, let's see. In the diagram of intersecting lines, angle 2 and angle 4 are vertical angles. Also, angle 2 and angle 3 are a linear pair, and angle 3 and angle 4 are a linear pair. By the linear pair theorem, angle 2 and angle 3, so angle 2 and angle 3, they are supplementary. Why? Because you can see they form like a semicircle. um they add up to 180 degrees because they're over a line, over a straight line. So they are supplementary. Now an angle 3 and angle 4 are angle 3 and angle 4, angle 3 and angle 4. Right here they form another semicircle, so they are also supplementary. So then measure of angle 2 plus measure of angle 3 is equal to 180 degrees, and measure of angle 3 plus measure of angle 4 is also equal to 180 degrees by the definition of supplementary angles. Okay, of supplementary angles. Wow. we're using the same word over and over. But it's like that's what it is. Also, don't get scared of using the same one, unless you need to only use one per, like you can only use the properties once. That's kind of a problem, but either way we don't need to use the property one, so we're good. Also, by the space, measure of angle 2 plus measure of angle 3 is equal measure of angle 3 plus measure of angle 2. So by the substitution property of equality, let me use another color. Oops. Substitution property of equality, B, because that's what I explained before. We have the same value and we are just substituting whatever, guys understand what I'm saying. We are just trying to substitute, like, we know that these two are equal to 180, so I can take this part and just move it so where the 180 is. That's basically substitution because I know the value. I know that it is equivalent to 180, basically it. Now, by this, okay, I put the v where it does not go. So by the substitution property of equality, measure of angle 2 equal plus measure of angle 3 equal measure of angle 3 plus measure of angle 4. So using the measure of angle 2 equal measure of angle 4. So basically, it is using the subtraction property of equality. Wait, another color. Subtraction property of equality. Why? Because what we are doing is we are subtracting negative, negative. We're subtracting measure of angle 3 from both sides, so we can cancel it out. So it cancel out, and this cancel out by subtraction. So using the subtraction property of equality, which is C, measure of angle 2 equal measure of angle 4. So angle 2 is congruent to angle 4 by the definition of congruence. And yeah, that's basically all. We'll continue next week using like more lines and angles and more things like that. It's kind of complicated, I get it, but it gets to be a really important part of the test. Um, I really recommend like reviewing it, trying to understand it because there are a bunch of questions asking about it. So guys, see you next week. Don't forget to go to Discord, ask me anything. There is a channel, you can put your question there. Just let me know. And also, if you're in my school and you see me, you can ask me. But either way, see you guys next week. Bye.